Hello, and welcome to the law of cosines video. Just some quick reminders about the law of cosines is that we only use the law of cosines in two scenarios. One, when we're given all three sides. The other is when we're given two sides and an angle with the angle being included, or side, angle, side. This is why it's so important to draw your triangle first, so you know whether you have side, angle, side for law of cosines, or side, side, angle for law of sines. Also, our law of cosines are c squared to a squared plus b squared minus 2ab cosine of c. B squared is equal to a squared plus c squared minus 2ac cosine of b. And a squared is equal to b squared plus c squared minus 2bc cosine of a. Now, they're really all the same equation, but you're going to want to use different equations at different times depending on what you're looking for. So, for instance, if you're trying to solve for angle b, you're going to want to use the equation that has angle b in it, kind of so on and so forth. Lastly, the methods that we use to solve for our law of cosines problem. First thing we're going to do is we're going to use our law of cosines, and you can continue to use your law of cosines all the way through, but it might be faster if from there your second step is to use your law of sines. And then lastly, we're going to use the triangle sum theorem. And that's really just when you're taking your angles away from that 180 degrees. And there you have it. So this is kind of the generalness, the kind of quick blurbs about law of cosines I want you to remember. Now we're just going to go through two problems and be on our way. The first problem that I want to go over is when our angle C is equal to 60 degrees, side length A is equal to 2, and side length B is equal to 3. So if we were to draw a triangle for this, A, B, C, side A is equal to 2, side B is equal to 3, and my angle C is 60 degrees. This is showing us an example of side, angle, side. So whenever we have side, angle, side, we're going to start by solving for that last side that we don't know. In this case, side C. So we're going to want to use the equation, I'll move this up a little bit, there we go, of c squared is equal to a squared plus b squared minus 2ab cosine of c. Reason being, it's probably going to be nicer to use the equation that is c kind of already by itself. But if we plug in what we know, we'll have c squared is equal to 2 squared plus 3 squared minus 2 times 2 again times 3 times cosine of 60 degrees. Now, I know that we know what cosine of 60 degrees is, but I'm okay if we just leave it as cosine of 60. We keep solving at c squared is equal to 4 plus 9 minus 12 cosine of 60 degrees, or c squared is equal to 13 minus 12 times cosine of 60. Now, remember, order of operations. This multiplication here between 12 and cosine of 60 is more important than the subtraction here. Multiplication comes before subtraction. So I cannot subtract these and just get cosine of 60. So from here, all I have left to do is square root both sides. To get c by itself, we'll have c is equal to the square root of 13 minus 12 times cosine of 60. Once I plug that into my calculator all at once, I'm going to get c is equal to 2.65. And there we have it. So remember, it's a side length round to your second decimal place. But now that we've found our side length and we've done our first step of law of cosines, now we can use law of sines. So let's solve for angle B. Let's have sine of 60 divided by 2.65 is equal to sine of B divided by 3. And we'll just solve for law of sines like normal. So we're going to cross multiply. Get 2.65 times sine of B is equal to 3 times sine of 60. I'm going to divide both sides by 2.65 And then to get b by itself, I'm going to sine inverse everything. So we'll have sine inverse of 3 times sine of 60, oops, there we go, divided by 2.65. When I plug all of that into my calculator, now that my b value is by itself, it's 78.6 degrees. Remember, it's an angle, so I want you to round that to the first decimal place. I'm going to go back, put that in my triangle. Lastly, we're going to use that triangle sum theorem and say, hey, I can find angle A by just taking 180 and subtracting the angles that I know of 60 and 78.6. And once I do that, I get 41.4 degrees. Draw that back in my triangle. And there we have it. This is a full law of cosines problem with side angle side. Let's just do one more. You might be able to guess where this is going. But first we're going to move this up. We're going to deal with a new situation where A is equal to 4, B is equal to 3, and C is equal to 6. Now you may be able to tell based on the information that is given. Ooh, that is not a straight line. There we go, much prettier. But we're given all side lengths, meaning that this is going to be an example of side, side, side. Now when we're dealing with side, 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 remember, always solve for your largest angle first. Solve largest angle first. And for us, largest angle, or for anyone, largest angle is across from the largest side. So in this case, since C, or 6, is our largest side, we're going to be solving for angle C first. And again, we will be starting by using the C squared is equal to A squared plus B squared minus 2AB cosine of C, because that's the equation that has angle C in it. So let's go through, plug in what we know. We get 6 squared is equal to 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of C. Once we simplify what we can, we'll get 36 is equal to 16 plus 9 minus 24 times cosine of C, or 36 is equal to 25 minus 24 cosine of C. Now again, just like last time, the multiplication here is more important than the subtraction. So we cannot combine the 24 and the 25. So instead, to get C by itself, I'm going to start by subtracting 25 on both sides. And we will get 11 is equal to negative 24 cosine of C. And then instead of adding 24 to both sides, I'm going to divide both sides by negative 24. And get negative 11 over 24 is equal to cosine C. And then ultimately, to get C by itself, I'm going to have to cosine inverse both sides. So we have C is equal to cosine inverse of negative 11 over 24. Or when I plug that into my calculator, I get 117.3 degrees. For this problem, we're only going to be rounding things to the first decimal place since we're only dealing with angles. But here we are, first step done. We've dealt with our law of cosines. Now let's do our law of sines. I'm going to solve for angle A first. So we'll set up sine of 117.3 divided by 6 is equal to sine of our angle A over 4. And now we just solve like we have been for the last few days. So we'll cross multiply. And then we'll divide both sides by 6. And then sine inverse both sides so that we have A is equal to sine inverse of 4 times sine of 117.3 divided by 6. And once I plug that into the calculator, I get 36.3 degrees. Don't forget to bring it back to your triangle. And then lastly, we're going to use our triangle sum theorem and say for angle B, that's going to be 180 minus 17.3 minus 36.3, all the angles that we know. And we'll end up with 26.4 degrees. 26.4 degrees, there we are. So that's what a side, side, side problem looks like for law of cosines. So we should know everything we need to know about law of sines, everything we need to know about law of cosines. Our last video for this unit is going to be about story problems. So you're not going to be learning any new math, but just practicing in the context of stories. So email me if you have any questions. I look forward to seeing you tomorrow.